Now these are the formulas for evaluating integrals involving exponential function. And in this video, I will not show you the verification of this formula, but let's proceed into our example. Now we have here an example that we are to evaluate the integral of e raised to 4x dx. You can pause this video and answer the question. Now using integration by parts, we let u is equivalent to 4x, and taking the derivative of 4x is du is equal to 4 dx, and our dx will be du over 4. Now this will be equal to the integral of e raised to u multiplied by du over 4. Taking the constant out, we have the 1/4 the integral of e raised to u du. Now, looking into our formula, this is similar to the first formula, where it's equivalent to 1/4 e raised to u, where our u is 4x plus c. Now, there's another way on writing our solution. We have here the integral of e raised to 4x dx. By taking the derivative of 4x, we'll have the integral of e raised to 4x 4 dx. Applying the neutralizing factor, we'll have 1 over 4. Now this will equal to 1/4 integral of e raised to 4x, and our 4 dx is simply the derivative of 4x. We can rewrite this one as 4x, and this will be also equal to 1/4 integral of the e raised to 4x. Now applying the integral sign, we will have 1/4 e raised to 4x plus c. Now this is another way of showing your solution. Now you will notice that we are using the chain rule of integration of our derivative process. Looking here, you will notice that we will arrive the derivative format of our function of e raised to 4x. Then if we apply the integral, we will arrive to our final answer, where our original equation is 1/4 e raised to 4x plus c. We have here another example that we are to evaluate the integral of dv over e raised to v. Now you can pause this video and answer the question. Now we can rewrite this form into this equation, that is e raised to negative v multiplied by dv. Applying the derivative of our function here, we can also rewrite this one as e raised to negative v times negative dv, where the derivative of v is negative dv. And applying the neutralizing factor, we have negative, and we can rewrite this form into this format, that the e raised to negative v is simply the derivative of negative v. And rewriting the equation into negative of the integral derivative of e raised to negative v, then this will be our original function, that is negative e raised to negative v plus c. By checking the negative e raised to negative v plus c, applying our differential operator, that is d with respect to v, it will equal to positive. This one will be negative times negative, and positive e raised to negative v dv. Hence, this is true to our integral function. Now we have here another example, that the integral of the quantity raised to 2 of e raised to t minus e raised to negative t dt. Now you can pause this video and answer the question. Using the FOIL method, that we have e raised to t minus e raised to negative t multiplied by e raised to t minus e raised to negative t. Our first term, that is e raised to t times e raised to t, is simply e raised to 2t. This is true since they have the same base. Then we will add the exponent of our term. Our outer term, that will be a negative e raised to t plus negative t, and our inner term, where this is negative e raised to negative t plus t, and our last term will become positive e raised to negative t plus negative t. Now simplifying our function, this will become e raised to 0, e raised to 0, and this will become negative 2t. Simplifying our equation, we will have e raised to t, and now e raised to 0 is simply equal to 1. That will be negative 1 plus negative 1. This will become negative 2 plus e raised to negative 2t. Now rewriting our given integral, this will become the integral of e raised to 2t minus 2 plus e raised to negative 2t dt. Now evaluating the integral with each term, we already know that this first term is equal to 1/2 since the derivative of 2t is 2, and taking the reciprocal will become 1/2 e raised to 2t, and this will become negative 2t. This is because the integral of 2 dt is equivalent to negative 2t. And lastly is the integral of e raised to negative 2t is simply negative 1/2 e raised to negative 2t plus c. This will be our answer, but we can further simplify this using the hyperbolic identities, where hyperbolic sine 2t is equivalent to 1/2 e raised to 2t minus e raised to negative 2t. Now simplifying our equation using the hyperbolic identity, taking the common factor of these two terms, 1/2 e raised to 2t minus 1/2 e raised to negative 2t is 1/2 multiplied by e raised to 2t minus e raised to negative 2t minus 2t plus c. And this is equal to the hyperbolic sine of 2t, then this will become hyperbolic sine 2t minus 2t plus c. Now this will be our final answer. You can check our solution by taking the derivative of this function, and it will prove to you that this will arrive to our integral function, and we can say that will be correct. Now we have here another example. This is a combination of exponential function and trigonometric function. Then you can pause this video and answer the question. The technique here is to take the derivative of sine 4x. Then this will become e sine 4x, and the derivative of sine 4x is equivalent to 4 cosine 4x dx. And applying the neutralizing factor, that is 1/4, is equal to 1/4 e sine 4x, and the derivative of sine 4x. And we can also rewrite this in this form, is the derivative of sine 4x. Now we will have our answer, that is the 1/4 e raised to sine 4x plus c. Now you can use the substitution method. Now I will show you the solution of substitution method by letting u is equivalent to sine 4x. Now the derivative of our function u, this will become du is equivalent to 4 cosine 4x dx, and applying our values of dx, then this will become du all over 4 cosine 4x. By substituting our newly assigned variables into our given integral, where e sine 4x cosine 4x dx is equivalent to the integral of e, where our sine 4x is u, cosine 4x, where our dx is equivalent to du all over 4 cosine 4x. Now we can cancel out the cosine 4x here. Then we can say that the remaining integral is equal to the 1/4 of integral of e raised to u du. Applying our first integration of exponential function, we have e raised to u, where our u is sine 4x plus c. Now we have here another example that we need to evaluate the integral of square root e raised to 3x dx. Now you can pause this video and answer the question. Now the technique here to evaluate this given integral, we must first express its equivalent powers, where this is equal to the integral of e raised to 3x over 2, where this is a square root dx. Now we can say that by applying the derivative of 3/2 x, this will become the integral of e raised to 3/2 x multiply the derivative of 3/2 x, where this is become 3/2 dx. Applying the neutralizing factor to eliminate this 3/2, we'll have 2 over 3 and rewrite our equation into 2/3 the integral of e raised to 3/2 x and the derivative of our 3/2 x. Again, rewriting our equation, 2/3 the integral of the differential of e raised to 3/2 x, and applying the integration of our function, this will become 2/3 e raised to 3/2 x plus c. By substitution method, we can let u is equivalent to 3/2 x, then taking the derivative of u, this will become du is equivalent to 3/2 dx. And our dx will equal to 2 du over 3. Then we can substitute the newly assigned variables to our given integral, where this is the integral of the square root e raised to 3x dx. And this is equal to the integral of e raised to u, where our dx is equivalent to 2/3 du is equal to 2/3 e raised to 3/2 x plus c. Now we have here another example that we need to evaluate the integral of 5 raised to 3 minus 2x dx. Now you can pause this video and answer the question. And now we can use the integration by substitution by letting u, that is equal to 3 minus 2x, then taking its derivative, where du is equivalent to negative 2 dx. Then substituting the newly assigned variables into our given integral, this is the integral of 5 raised to u, where our dx is equivalent to du over negative 2. Then this will become negative 1/2 the integral of 5 raised to u du. Now you will notice that the a here is a constant. This is a similar image of our solution, and then we can use this second formula by taking the negative 1/2 multiply by our a, where this is equal to 5 raised to u, where our u is 3 minus 2x all over ln 5 plus c. And simplifying our answer, this will become negative 5 raised to 3 minus 2x all over ln 25 plus c. Or you can also write this as negative 5 raised to 3 minus 2x over 2 ln 5 plus c. The 25 here is, we can take we can place the 2 to our power of our 5, that will become ln25. You can please review the rules and logarithmic powers. Now we have here another example that we need to evaluate the integral of 3 raised to x 2 raised to x dx, and you can pause this video and answer the question. Now, the technique here, notice that they have similar power, then we can rewrite this one as the integral of 3 multiplied by 2 raised to x. This is true by applying the power rules of exponents. This is equal to 3 raised to x, 2 raised to x, and dx. And this will be equal to the integral of 6 raised to x dx. Now, applying our second formula, then we can write this one as 6 raised to x over ln 6 plus c. Now, that will be our answer. Now, we have here another example that the integral of 1 minus 2 e raised to tan x multiplied by secant squared x dx. Now, you can pause this video and answer the question. We must first distribute the secant squared x to the parentheses. This is equal to the integral of secant squared x dx, secant squared x dx, minus 2. I'm taking 2 out since this is a constant. The integral of e raised to tan x secant squared x dx. Now, we already know that the integral of secant squared x dx is simply tan x. Now, in the second term, we already know that this is negative 2, and the integral of applying the derivative of tan x, that is e raised to tan x multiplied by d tan x. Because the derivative of tan x is simply the secant squared x dx, then we can say that the tan x minus 2, the integral of the differential of e raised to tan x, will become tan x minus 2 e raised to tan x plus c. That will be our answer. Now we have here another example that we need to evaluate this term. You can pause this video and answer the question. Now we must find the factors of our denominator. This is equal to the integral of e raised to 2t dt all over. We already know that this is 1, then the factor of 1 is 1. And the factor of 9e raised to 4t is 3e raised to 2t. Then we can say that this is equal to 3e raised to 2t plus 3e raised to 2t. This will equal to the integral of e raised to 2t dt all over 1 plus 3e raised to 2t squared. Now, by applying the integration by substitution, where our u is equivalent to 1 plus 3e raised to 2t, then taking the differential of our u, then this will become du is equal to 6e 2t dt. Then substitute our newly assigned variable to our equation, then this will become the integral of e raised to 2t all over u squared multiplied by our dt. We're taking the reciprocal of this term. We will have du all over 6e 2t. And we can cancel out the e raised to 2t. Then we are left with this function 1 over 6, the integral of u raised to negative 2 du. This is true because our power is in the denominator, and if we take the power into the numerator side, then we will take the negative of our power. Then, applying the integration of powers, this will become equal to negative 1/6 times u raised to negative 1 plus c. Now, we already know that our u is 1 plus 3a 2t. Then we can write this one as negative all over 1 plus 3e raised to 2t plus c. Now, this is our answer. Now, we have here another example that we need to evaluate the integral of 3 raised to 2y dy. Now, you can pause this video and answer the question. You will notice that this is similar to our second formula. So, our goal here is to have this kind of answer. Now, we can let u is equal to 2y. Taking the derivative of our variable u, this is become du equal to 2 dy. And substituting our newly assigned variables into our given integral, then this will become the integral of 3 raised to u multiplied by du over 2. Taking the constant out, we have 1/2 the integral of 3 raised to u du. Then applying the second formula, this will become 1/2 multiplied by 3 raised to 2y all over ln 3 plus c. Simplifying, we will have 3 2y all over ln 9 plus c. This is 2 by taking the square of our values of 3 here. Then they will become ln 9. Or we can write our final answer into this form, that is 3 raised to 2 multiplied by raised to y all over ln 9 plus c, and this is equal to 9y all over ln 9 plus c. Now, this is our final answer. Now, that will be all in this video. I'll see you around on our next topic.